Hey guys, so today we're going to learn about exponential uh, functions and look at two different types of exponential functions. So an exponential function is anything that's a value not 1, and so let's use 2, it's very common, and it's raised to a power of x. And this is something called an exponential function. It's an exponential growth, right? And what you'll notice is it's not linear. It doesn't go up at a constant rate of change, right? It's pretty flat over here, and then it goes starts to get steeper and steeper and steeper, and eventually it gets really, really steep. If I zoom out, you'll see how steep it gets, right? And this is called an exponential function. An exponential function, like I said, does not have a constant rate of change. Instead, it has something called a constant ratio. So if I go to a table of values here, let's say from like -2 to like 5, okay? And you see each of these points and they'll plot them over here. And if you look at as x goes up by 1, what's happening to y? And it might be hard to see with the decimals, but look here, 1 to 2, 2 to 4, 4 to 8, 8 to 16, 16 to 32, right? This is called exponential growth. What is the common ratio that it's being multiplied by now each time? Times 2, times 2, times 2, times 2, times 2, even here. So you could see eventually it's going to start going up very quickly, right? And this is kind of actually what we're going through right now in the world, where they're trying to say this whole, you might have seen, flatten the curve. They don't want exponential growth. With cases of the coronavirus, they kind of want it to flatten out. They'd rather it not be exponential, right? You don't want it to go up like this and go quicker and quicker and quicker up. So that's the whole flatten the curve thing. Cool. So what happens as we change, instead of 2 to the x, what if I graph something like 4 to the x? And let me just change that color because they're too similar. Let's use blue. And you can see what's happening with 4 to the x. Well, it's going up faster. And why is that? Because now the common ratio is 4. So it's multiplying by 4 each time. Times 4, times 4, times 4, times 4. And if you go backwards, divide by 4, 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 and so on and so on and so on. Right? Okay, cool. Now, the next thing we want to look at, though, is you don't want to do 1 to the x. If you do 1 to the x, really, look, this is a flat line because 1 raised to any power is 1. So what happens if the number is less than 1, though? What if we do 0.5 raised to the x? And now you'll see something a little different. Again, let me just change the color here. Something different. Let's do purple. Okay. Here, over time, what's happening? Well, it looks like it's as x goes up, y is going down. So let's see. Table of values. Yeah, look. As x goes up, it's divide by 2, divide by 2, divide by 2, divide by 2, but really not divide by 2. Well, it is divide by 2, but better it's multiply by, because everything is being multiplied, multiply by 2, multiply by 4, multiply by a half each time, right? So two different types of functions here. The blue and the red are called exponential growth. Oh, as x goes up or as time goes up, it's going up. The purple one is called exponential, and you probably have heard this before, decay. It's going down at an exponential rate by multiplying by a half, 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 half. Now, some things that are interesting, if you multiply a number by a half or divide a number by 2, it's going to get smaller and smaller and smaller, but it's never going to be 0. It looks like this purple line is at 0, but if you zoom in, you'll see it's not really 0. It's going to keep getting smaller and smaller. And you might say, oh, eventually it'll get to 0, so let's go to some really big numbers. What about here? It looks like it's just on 0. Well, let's zoom in. I have to zoom pretty far, but let's see. Might break the iPad. Zooming in. I think I went too far. It's too hard to see. Yep, I broke it. Sorry about that. Let's not go that far out. Let's go somewhere like 12. Here you'll be able to see it. And there you go. Eventually you can see it's not at 0. It's just getting smaller and smaller, but not 0. What does that mean for our graph here? Well, that means that we have horizontal asymptotes, right? Asymptotes are those invisible barriers that functions cannot cross. And the same thing over here. Because if you're going left, you're dividing by 2 instead of multiplying, or dividing by 4 instead of multiplying. It's not really 0. It's just getting close to it. All right, it's getting close to it. All right, so that's my little explanation for exponential functions, exponential growth, and decay. So let's look at the lesson a little bit. So sketch the function 2 to the x on the set of axes. Now, you can just go to the calculator and use your table of values. We've actually done this already. So 2 to the x, well, let's see. I'm going to go back here. I'm going to only graph 2 to the x. I'm going to look at my table of values for f of x. It should look like this. Let's see. The red one. So we get 0, 1, 1, 2, 2, 1, 2, 3, 4, 3, 8. And then as you go left, it's divided by 2, so it's negative 1.5, 0.25, and it's just going to be like this. So when we sketch this, just make sure you don't go underneath it, and that's fine. I just draw an arrow and an arrow. So this is 2 to the x. This is y equals 2 to the x. Exponential growth, right? Because it has a common ratio of 2. It's multiplied by 2 as x goes up by 1. All right, so just some features of exponential functions. An exponential function is any function that has some base raised to the power of x. How do you know it's exponential? The exponent is a variable. Okay? The shape, most graphs, exponential graphs will have the same arc shape, either growth or decay, and like we said before, it does not have a constant rate of change, but does have a constant ratio. It's what you're multiplying by as x increases. Okay? Some other facts, the domain is all reals. What does that mean, that the domain is all reals? Let me just delete these other two real quick. That means that it goes forever left and forever right. We know that. Any x can be any number. You can raise any number to any power, positive or negative. You can raise to negative exponents. That's fine. The range, well, horizontal asymptote, so it never goes below 0. So y such that y is greater than 0. It's in quadrants 1 and 2 usually, unless you transform it. The point 0, 1 is always on the graph, because anytime you raise something to the 0 power, if x is 0, 2 to the 0 is 1. Anything to the 0 is 1. And it can either increase or decrease. Okay, so let's look at some questions. The graph shows a function in the form f of x equals some number b raised to the x. Well, look at this graph. It's growth or decay. As x goes up, y is going down, so it's decay. So what must be the value of b? It must be a decimal between 0 and 1, right? So decay is if your base is between 0 and 1. It can't be 0 and it can't be 1, but it can be anything between, so this is choice B. All right, let's take a look here. Given f of x equals 1/2 to the x, 0.5 to the x. Graph the function f of x minus 4 plus 2. Okay, so now check it out. These are our transformations. Remember, inside and negative means right 4. Outside and positive means up 2. So we're going to take every point, we're going to go right 4 and up 2. 1, 2, 3, 4, up 2. 1, 2, 3, 4, up 2. 1, 2, 3, 4. And now this could get kind of annoying, as you see, but what a better question, it's going to be something like this, but how do I know where to flatten it out? Well, look, what is the horizontal asymptote of the blue one? It's 0. So if I go up 2, the horizontal asymptote is going to be right there. The line cannot cross that, so that makes it a lot easier to sketch this. So what are the asymptote of f of x and h of x? Well, for f of x, the asymptote is going to be the line y equals 0. But for h of x, it's going to be the line y equals 2. Okay. Now, domain and range of f of x and h of x. Well, let's look at f of x first, the blue one. Forever left, forever right, and it can't go below 0. So the domain is all reals, and the range, y is greater than 0. Doesn't go below that. But for h of x, domain, still forever left and forever right, so that's all reals. Range, now y has to be greater than which value? Well, it doesn't go below 2. Right. Graph, given the function f of x equals 2 to the x on the axis below, it's not there. Graph g of x, let's just do this, 2 to the x plus 1 minus 3 over the interval from negative 2 to 2. So let's do this. Let's try it out. So 2 raised to the x plus 1 and then minus 3 on the out, so make sure you go over. So we got a graph here, and we want to graph it between negative 2 and 2, it says. So table of values from negative 2 to 2. Let's graph it. So negative 2, negative 2.5, negative 1, negative 2, 0, negative 1, 1, 1, and then 2, 1, 2, 3, 4, 5. So just graph this. Explain what transformation occurred. Well, what did happen? Let's take a look. It definitely went down 2 because should have hit 0, 1. Anything else happen? Well, what's that plus 1 up there doing to it? Is it going right? Is it going left? I don't know. Let's take a look. Let's see what happens if I get rid of the plus 1. And I just put 2 to the x. Let's see. Look at the graph. Yeah, it looks like, did it move right? Let's see. If I put plus 1, it moves left. Yep. So it went left 1, down 3. All right. Let's skip domain and range for now. All right. Let's skip ahead a little bit. Let's look at some multiple choice. Which function represents exponential decay? Now be careful with here. This is a tricky question, and I remember this from the Regents in Algebra 2. Which function represents exponential decay? A lot of people want to pick 3 right away, but really the easiest way to tell if something is exponential decay is to graph it. So how do we answer this? Just graph it. Let's see, 1/2, and that raised to the negative x. Is that decay? It's not. People always want to pick that one, but it's not. Just graph them until you find the one that is decay. Let's see. I think it might be 5 raised to the negative x. There it is. Choice 4. Cool. All right, I think that was good. So hopefully have a good idea about what's going on. And there you go.